Hi and good afternoon. We were from group number 5, section 2. We want to presenting about our group project industrial visit. Our lecturer name is Professor Madya TS Dr. Kok Boon Ching. Our group consists 6 members. Okay, first Muhammad Afizuddin and me, Nurhanan Afika binti Imran, also Izzati. Next is Nurul Fatin Nabila binti Ishaq, Muhammad Zofri bin Ismail, also Muhammad Syahir bin Masnur.
Okay, hi. My name is Izzati binti Muhammad Yani, nometric CE230054 from Group 5. So today, I will be discussing the Tanjung Energy TBE power plant, also known as T4, that is a subcritical coal-fired power plant located in Johor, Malaysia. It's developed by Malakoff Corporation. Other than that, plant type is thermal power plant that generate capacity of 2,100 MW. Malakoff Power Plant Berhad operates the power plant under a 25 years operation and maintenance. Many machines that we can observe, such as generators, motors, and so on. In addition, each machine also has different function so that the energy produced is balanced according to the required capacity. We were given a task to make a study tour which aimed to understand more about how the power plant works to generate energy and how each machine thermal power plant works to generate and store the energy to customer. Okay, that's all for me. Thank you.
Okay, hi. My name is Nurul Fatin Nabila binti Ishaq and my matrix number is CE230045. Okay, for this part, I will be presenting an overview of the Tanjung Power Plant, a key energy infrastructure project. Okay, for the first, I will begin with the ownership and basic details of the Tanjung Power Plant. Okay, the plant is primarily owned by Malakoff Corporation Berhad, holding a 90% stake, and while Kadar SP hold the remaining 10%. Okay. For the type of plant, this is a coal-fired thermal power plant utilizing subcritical technology. Subcritical plants operate at lower temperatures and pressure compared to supercritical and ultra supercritical plants, making them more conventional but less efficient. Okay, for the capacity, the plant has a total capacity of 3 units, each generating 700 megawatt, bringing total to 1,100 megawatt. And for project cost, the project cost is approximately 7.1 billion ringgit. The significant investment reflects the scale and the complexity of the project. Okay, for the fuel, the main fuel used is pulverized coal, specifically bituminous and subbituminous coal. For startup and shutdown operation, light fuel oils is used to ensure smooth transition. Okay, now let's look at the timeline for the plant's commercial operations. Okay, for Unit 1, commence commercial operation on 28 September 2006, and the Unit 2 follow on 28 February 2007, and finally Unit 3 started on 31 August 2007. Okay, in conclusion, the Tanjung Power Plant is a vital component of our energy infrastructure, providing substantial power capacity through advanced yet conventional coal-fired technology. Okay, that's all from me. Thank you. Okay, for this part, I will explain about the project structure of the Tanjung Power Plant. Tanjung Power Plant. So this slide outline the key organization and their respective responsibilities. Okay, at the top we have Malakoff Corporation Berhad, the primary owner and operator of the Tanjung Power Plant. So Malakoff is responsible for the overall operation and maintenance, or known of OM services, and Fitchner GmbH and Rentak G2 Project Management Sendirian Berhad are involved in engineering and project management aspect. So the main construction and engineering work is managed by the Sumitomo Zealand consortium. So this consortium is divided into 2 main entities, which is Zealand and Sumitomo Corporation. Okay. For Zealand construction, Sendirian Berhad is responsible for civil and building service works, and Sumitomo Corporation is divided three keys. Through is associated companies, which is Ishikawa Harima Heavy Industry, focus on the boiler island, including boilers, flue gas, and so on. And then Toshiba Corporation, which is Turbine Island. Toshiba Corporation, which handle the switch yards and transmission works. Okay, in summary, the Tanjung Power Plant project structure involve a coordinate effort among various specialized organization, each responsible for different critical aspect of the plant's construction and operation. Okay, that's all from me. Thank you.
There is four components that I put in an electrical machine application. The first one is turbine generator. The power outputs from between 1000 kilowatt to 25,000 kilowatt. And the turbine generator's primary function is to generate electricity by converting steam energy. And how it works, the steam turbine was to turn the steam into mechanical energy. And then for the operation, it's burning the coal heats water to create steam, which spins the turbine. And for the generator, the purpose was to turn the mechanical energy into an electrical energy. And for the operation was to spinning the turbine drive the generator producing an electricity. And for the motor, it used to isolate electrical loads from power supply lines, and it consists of an electrical generator driven by an electric motor. This is used to convert the electrical power frequency, voltage, and phase. It is turned by the steam turbine or internal combustion engine, unlike a conventional electrical generator. And for its rate, it starts from 75 or 158, 190, 425, and 695 kVA direct coupled frequency converter motor generator set for 50 Hz to 60 Hz conversion. And they are also used to isolate electrical loads from the electrical power supply line to eliminate spike and variation in large power supplies or provide phase matching between different electrical systems. For the third component was a switchgear and circuit breaker, a medium voltage switchboard and including voltage to 24 kV, current rating up to 3500 amps and up to 31.5 MVA. Fault rating capacity. Our switchboard are built with the ABB Unigear ZS1 enclosures, incorporating vacuum or SF6 circuit breaker technology and motor switching device for the transformers and rotating machinery. The main function is to protect and control. Switchgear and circuit breaker protect the electrical network within the plant and ensure safe operation by isolating faulty sections. And last was an auto transformers, 16 MVA and 72.5 kilovolt and above. Oil immersed transformers are described as power transformers. Power transformers require distinct expertise and experience in particularly insulation and cooling issues. For the main function, voltage regulation, auto transformers adjust voltage level within the power plant for efficient electricity distribution and transmission. And how it works? A single winding. Unlike traditional transformers with separate primary and secondary windings, auto transformers have a single winding that act as both. Voltage adjustment, a portion of the winding is taped to provide the desired voltage transformation, either stepping up or stepping down the voltage as needed.
Hi, my name is Muhammad Zofri bin Ismail and my metric number is CE230149. So for the problem or issues related to the specific electrical machine, we have generator issue. The first is overheating as excessive heat due to inadequate cooling can damage generator components. And second is vibration, misalignment, imbalance, or mechanical failures can cause harmful vibration. And the third is rotor and stator problems. Issues like winding failure, insulations breakdown, and bearing wear can affect the performance of generator. For the last is excitation system fault. Problems in the excitation system can lead to unstable voltage and frequency regulations. So for the transformers is insulation degradation. Over time, the insulation in transformers can be deteriorate, leading to failures. Second is short circuits and ground fault. This can cause severe damage to transformer windings and core. And third is cooling system failures. Inefficient cooling system can cause overheating and damage to transformers. Oil leaks. Transformers rely on oil for cooling and insulation. Leaks can be hazard and lead to failures. So for the motors, the first is bearing failures. Motors often suffer from bearing wear and tear, leading to operational failures. And second, overloading. Continuous overloading can cause excessive heat and damage motor windings. Third is mechanical stress, misalignment, improper installation, and mechanical shocks can be lead to motor damage. And the last is electrical failures. Issues such as phase imbalance, short circuits, and insulation failures can impact motor performance. So for the switchgear, we can see contact wear and tear. Frequent switching operation can wear out contacts, leading to poor performance. Then aging infrastructure. Older switchgear can suffer from various reliability issues due to aging components. Then insulation failures. High voltage stress can cause insulation breakdown in switchgear. For the last is circuit breaker failures. Malfunctioning circuit breakers can fail to protect electrical system effectively. Last but not least is power quality issues. Is harmonics. Nonlinear loads can introduce harmonics, affecting the quality of power. Second, voltage surge and surge variation in voltage can impact sensitive equipment and overall plant performance. Last is frequency variations. Deviation in frequency can affect the stability and efficiency of electrical machines. So that's all from me.
For the next part is suggestion for improvement. There is 5 suggestions that we make to help Tanjung Bean Power Plant to be improved in the future. So the first one is implement predictive maintenance. So what it means is it have to be advanced monitoring tools like vibration analysis, thermography, and oil analysis to monitor the condition of electrical machine in real time. Next, there is upgrade aging infrastructure. So we have to replace obsolete equipment and gradually replace aging transformer, switchgear, and other electrical machines with modern and more efficient one. Then there is modern control system. What it means is we have to upgrade to advanced control system with better diagnostic capabilities and automated for detection. For the fourth one is implement redundant system. So they have to design critical system with a redundancy to ensure they continue operation in case of component failure in the power plant. And for the last part is optimize load management. Tanjung Bean Power Plant have to optimize the distribution of electrical loads to prevent overloading of any single machine. So all of these suggestions have been analysed and have been researched by us to give the better suggestion for improvement to the Tanjung Bean Power Plant.
Hi, my name is Nur Hanan Afiqah binti Imran and I want to presenting about the discussion. The first point is coal-fired power generation process. Observe the actual process of coal-fired power generation, including the handling at coal, combustion process, and energy conversion. Firstly, the coal handling. The coal handling process involves several stages. Firstly is coal delivery and storage. Second, coal preparation, and the third is convenience. And number 2 is combustion process. The combustion process converts the chemical energy in coal into thermal energy. This involves the following stage. Firstly is coal pulverization. Number 2, feeding the boiler. Number 3, conversion. And the third is heat transfer. 3 point, energy conversion. The thermal energy from combustion is converted into mechanical and electrical energy through the following process. First, steam generation. Second, steam turbine. Third, generator. And the fourth is electrical transmission. For this discussion for number 2 is engineering and the technologies aspect of subcritical thermal power plant. Exposure to the engineering and technological aspect of subcritical thermal power plant, including the design and operation, boiler, turbine, and generator. Subcritical thermal power plant operate at pressure below the critical point of water, where distinct liquid and gas phase exists. These plants are widely used due to the established technology and reliability. The overview focuses on the engineering and technological aspect, specifically the design and operation of boiler, turbine, and the generator. Firstly is boiler design and operation. The boiler is a critical component in a subcritical thermal power plant, designed to convert the chemical energy into the cold thermal energy. Design is furnace, water and steam circuit, burner and air preheater, also superheater and reheater. The operation is number 1 is full handling, number 2 is heat transfer, and number 3 is steam flow. Number 2 is turbine design and operation. This steam turbine convert thermal energy in steam into mechanical energy. Design high pressure HP turbine, intermediate pressure IP turbine, low pressure LP turbine, also blades and rotor. The operation are steam admission, expansion and rotation, efficiency optimization. Number 3 is generator design and operation. This generator convert the mechanical energy from the turbine into electrical energy. The design is rotor and stator, winding and cooling system. The operation is electromagnetic induction, power input, also the control system. The point of number 3 of discussion is importance of industrial visit in the energy sector for the students. In industrial visit, students meet professionals in the field, understanding their roles and gaining the inspiration for potential career path in the energy sector. Industrial visit provide invaluable opportunities for the student to bridge the gap between the academic learning and real-world application. When students visit energy sector facilities, they gain first-hand exposure to the practical aspect of their field of study, make professional, and also understanding their roles. Here's detailed explanation on how this visit inspire and inform students about potential career path. Industrial visit provides students with exposure to real-world operation, allowing them to witness the actual function of power plants, refineries, or other energy facilities. They can see how theoretical concepts from their textbook are applied in real-life scenarios. Observing advanced technologies and machinery in action help them understand the complexity and scale of industrial operation, including how various the engineering principles are integrated to express the efficiency and safety. Number 2 is interacting with industry professionals during industrial visit allows students to understand the diverse roles within the energy sector by meeting engineers, technicians, managers, and other professionals. This interaction clarifies job titles and responsibilities. Professionals share their career journey, provide insight into the education, skills, and experience required for various positions, helping students potential career path and the step needs to achieve them. Engaging with this expert can also lead to mentorship opportunities when the student and the professional offer advice, support, and even internship or job opportunities to promising students. Number 3 is Industrial visit allow students to gain practical knowledge through hand-on learning by seeing and sometimes interacting with equipment and their processing. This hand-on experience supports their academic learning and provide a deeper understanding of practical application. Additionally, witness how professionals tackle real-world challenge extends to the student problem-solving, their skill, teaching about them, the practice constraints and solutions that are not always covered in academic settings. Overall, this visit play a crucial role in shaping student career aspiration, enhancing their education experience and preparing them for successful career in the energy sector. Okay, next is the conclusion. Tanjung Power Plant plays a crucial role in Malaysia's energy infrastructure by providing a substantial electrical generation capacity. The plant is equipped with advanced technology and strong environment protections to ensure efficient and reliable power delivery while reducing its ecological impact. Its consistent operation and strict adherence to frequency the supply requirement are essential for contractual obligation with Tenaga Nasional Berhad supporting the nation's economic growth and energy security. Furthermore, the industrial visit to Tanjung Power Plant offers students a comprehensive learning experience, combining technical knowledge, practical insight, and an understanding of the economic and environmental aspect of power generation. The visit can significantly enhance their education journey and prepare them for future careers in the energy sector.